Good morning, everyone. We shall get started. And as we promised yesterday that we're going to do some factoring. Okay. And as we go through the factoring, we will notice and make connections with what we have gone over in the series of about factoring. Okay, so let's look at the first question in basic 37. Number 1, we have 3x raised to the power 3 minus 12x. I would imagine everyone know how to factor this, right? So you're going to factor out the 3x. This is factoring by GCF, right? So x squared minus 4. And before we factor, and we know that this is a degree 3 polynomial, and the coefficients are what? The coefficients are integers. If the coefficients are integers, the coefficients are real numbers, and if they're real numbers, they're complex numbers. So according to the fundamental theorem of algebra, it can be factored into 3 factors, maybe with complex, complex factors, okay? But real numbers are special cases of complex numbers. Therefore, we continue the factoring, right? And we get x plus 2 times x minus 2. So we got 3 factors, degree 3, we get 3 factors. Okay, we ended up with 3 integer factors. Okay, we end up with 3 integer factors, 3 real number factors. And this happens too. Okay, a lot of the situation we have dealt with in elementary algebra class or intermediate algebra class. In fact, a lot of factoring situation you are going to see in your future classes. They're primarily, you are going to be able to factor them pretty easily. But we need to be aware, the theory tells us, right? In some extreme cases, I wouldn't call them extreme cases, in some cases that the factorings is guaranteed by a fundamental theorem of algebra. It's just, you just have to identify the factors, but within, as we learned yesterday, within the real number, right? If you have real number coefficient within real number factors, you may have linear and quadratic. Okay, so we're going to see this as we move on. Okay, so the next one, I want you guys to give it a try. How about you guys try it? Okay, number 1 is to factor, and number 2 is to solve equation. Solving equation part, you just set it equal to 0, right? Just set it equal to 0. If this is 0, we know solving equation is an if statement, right? If this is 0, and then the product is 0, right? It's an if statement. So these are statements. Okay, still don't forget. And these are if statement. Okay, so these are the 2 different types: statement, if statement, equations, expressions, and so on and so forth. And if that's equal 0 and the other one will be equal to 0, and then we will be using the, I was just checking if the door is, excuse me, if the door is open. All right, then we use principle number 5, so we get x equals 0, right? Or x plus 2 equals 0, or x minus 2 equals 0. Okay, let's see. I will answer some questions as I promised to an inbox message from yesterday. Okay, so later. Okay, so let's get this started. Okay, so the final solution will be x equals to -2. Okay, so these are the solutions. So our solutions are these. Okay, so these are the two types we're gonna be doing, and one is on factor, and the other one is on solving for x. And you can see that when we do these equations, when we work on these factorings or solving equations, we need to be aware. I want you to be aware of the theories we talked about. Okay, so that's what we want to reflect on. Okay, so I'm gonna give you some time to do number 2. I'm sorry, number 3 and number 4. Okay, so try number 3 and number 4 just to warm up. Okay, there's some more other equations coming our way. Okay. You guys have number 3, number 4 in front of you? So 5x raised to the power 4. This is a factoring. Okay, that's a statement. Okay, and the other one is an equation, is if statement. Okay, I'm gonna just excuse myself for a couple minutes, and I will be right back. All right, I'm back. factoring. Use all the techniques you still remember, or and we're about to review. Okay, and so I'm behind you. Okay. So equipped with the theory, we should understand that we have degree 4, and we should expect to have 4 factors. But these 4 factors some of them may be complex, but that's okay. But since we only want real numbers, right? And the instruction in 37 says factor completely over C. C means complex numbers, right? So we know that the theory guarantee we are going to have 4 factors. We are, okay? And some of them may be complex numbers. So we want to be aware of that existence of the theory, and that it guarantees that we're heading in that direction. And if we end up with some real numbers, that's great, because real numbers are complex numbers, right? Real numbers are complex numbers. So now we have x squared plus 2x minus 3, and this can be factored as x plus 3 times x minus 1. You guys got it? Okay. So this is pretty straightforward, right? So it gets a little bit more interesting, okay? Because in some situations, so let's solve this equation. If this statement equals 0, then its factor form is also equal to 0, okay? And so in the end, we'll get x equals 0, or x equals to, I'm just going a little faster, and -3, or x equals 1. Okay. Number 7. Can we factor number 7? And then the answer is of course, right? Every polynomial with the theories we reviewed, every polynomial can be factored. If the question is, can you factor that polynomial? The answer is always yes. Why? Fundamental theorem of algebra. But whether we actually can make it happen, that's going to take some work. Okay. So now we have 6x squared plus 11x minus 21. There are some techniques you can use, or those techniques that you learned in your algebra class, right? Which is, I think I mentioned one yesterday, didn't I? I mentioned one yesterday, so I'm going to bring that back up. Okay, that's one technique, but you have learned so many different techniques over time, right? It's using this table. And there's a handwritten version. When I learned it, and I was a student, when I was learning it, it was more of a handwritten version. Okay, I'm going to show you the handwritten version. Because most of us are doing this handwriting, by hand. Okay. And I set up this table is because the convenience that for classroom use. If I use this technique, right? It's a trial and error. Remember, it's a trial and error. Okay, and it works for integers. It works for integers. If we have decimals, and we're going to be in big trouble, right? It still can be done, okay? The same idea still applies. It's just, you know, how easy it is. Okay, so let's look at one of the techniques. 6 equals to 2 times 3, right? Well, naturally we'll think of that. 6 is also equals to 1 times 6, okay? It also equals to -1 times -6, equals to -2 times -3. So you have all these options we're gonna try. Okay, so if I make a table on the side, okay, and 6, right? It equals to 2 times 3, 1 times 6, etc., etc., right? -2 times -3, -3 times -2, all these different options. -21 is equals to what? -3 times 7, right? 3 times -7. And what else? 1 times -21, right? 1 times -21. Did you guys recall doing that? You might be doing it in a different setup, because these methods are being taught in many different ways. The textbook teaches a certain way, and the different teachers teach certain different ways. And I'm not promoting my way. I'm just showing you, or use this opportunity as a review, that on the one hand, the theory we reviewed yesterday guarantee we are going to have 2 factors. And in practice, it's going to be a lot of work, a lot of trial and error. So suppose I'm going to try one of the factors, right? Say -3 times 7. Okay, -3 times 7. Okay. From what we talked about yesterday, we're just going to do the cross multiplication. Okay, we're cross multiplying these two. Let me use a more prominent color. Okay, I'm going to use a red. Okay, and we're going to cross multiply. You don't have to use my way. Any other way you are more comfortable with is fine with me. Okay, and we cross multiply 3 times -3. That's going to be negative. That's going to be -9. And 2 times 7. That's a 14. You add these two numbers, and we're getting. What are we getting? -9 plus 14. +5, right? And 5 does not match 11, because our goal is to get 11 matched. And we didn't get it. Guess what? We have to try again. Because we have all these other options to try, right? We have all these other options to try. So let's try 3 times -7, right? So 3 times -7. And will that make it? Well, this is going to be +9. This is going to be -14. And this is going to be -5. It doesn't match either. It doesn't match either. And what else do we do? This is going to get really a lot of work, right? How about we do 1 and 6? Yeah? Yeah? Try that. 6 times 3, that's 18. Right? 1 times -7 is -7. Oh, we make it. Voila. Okay, we match the +7 in here by playing with all these combinations, Remember trying those in the technique you learned before in elementary algebra, in your algebra classes? Wow, that was work. And then we can compose our factors, right? The first row, the 1 will be used for 1 times x and +3. Oops, +3. The next one, the 6 will be used for 6 times x minus 7. We got our factors. Okay, so our factors will be x plus 3 times 6x minus 7. Right? That is work. That is work. And of course, you can check your answer, right? When we check our answer, what do? We FOIL, right? We FOIL. We FOIL. We FOIL this, and we should get exactly that. I'm leave that FOIL part for you. You guys can do the FOIL, no problem, right? Oh, geez, these random advertisement. Okay, so we got our factor. We got our factors, and then of course we can do number 8. Okay. So number 8, I'm gonna make it just smaller back. Okay. So on the if statement, if, right, if that's 0, then the product is 0. Product is 0. Okay, so I'm gonna clear that. And then we are almost done. Okay, and then we use principle number 5. We hear that principle number 5 all the time, don't we? 7/6. So these are 2 solutions. In fact, the whole reason, okay, the major reason we factor is because we will have opportunity to use principle number 5 or principle number 6 in the if statement setting. In the if statement setting, okay, you will see this a lot more. You'll still see this a lot in calculus classes. Okay, and then you say, well, I'm trying all these techniques. I have to try all of these, right? All these combinations. Is there any shortcut to do the factoring of quadratic? And I can tell you yes. I can tell you yes. Okay, suppose I don't want to go through this. Okay, I have done enough. For example, right? I've done enough, right? All these trial and errors, no problem. We actually have a systematic way to find you the factors each time on quadratic. Did we address this in one where we were doing quadratic? I think we did. Okay, but if you don't remember, then maybe we didn't. Okay, here's why. Right? Yesterday, when we talk about the rational zero theorem, we say that for any polynomial with real number coefficients, we can factor them into linear or quadratic forms, or irreducible quadratic. Remember that theorem? Okay, so let me bring that back up. Okay. Linear and quadratic factors, this theorem. Very important theorem. Okay, linear and quadratic factors. Every polynomial with real coefficient can be factored into products of linear and irreducible quadratic factors with real coefficients. So if we have real numbers and we don't want to deal with complex numbers, then we can factor that. But this exercise asking us to factor completely in complex numbers. So before we get into complex numbers, we are guaranteed to have linear or irreducible quadratic, right? So let's see if we have a common way to solve to factor quadratic. And there is a way. There is a way. And what is this way? And here it is. We just did number 7, number 8, right? I'm putting on a note. Okay, I'm going to show you some algebra. Okay, I'm going to show you some algebra. Are you guys ready? Okay. Suppose we have the answer for number 8, right? And now we want to go back to factor. Oh, well, we already factor it, right? How are these? The question is, what is the relationship between the roots and the factors? That's the question. What is the relationship between the roots of a quadratic, any quadratic, and the factors of the same quadratic? What is the relationship? Right? What is a relationship? What is a relationship? You know, a couple hundred years ago, somebody noticed that. Somebody noticed that. Okay. So anybody have any comment? Anybody gonna tell me? Do we know that relationship? Relationship. Does anybody know the relationship? And here's the relationship. Okay, so I'm going to show you. The relationship is observed. Okay, so let's look at some observation. Okay, I want you guys to come up with your conclusion. Okay, the observation started from here. Okay, let's start with a simple example. Okay, and we can factor them, can we? We can factor them, right? We get x minus 2 times x minus 3. And that equals to 0. Easy, right? And then what you get? You get the roots. You get the roots. X equals to 2 or x equals to 3. Do we observe some relationship between the root and the factors? These are the roots, right? These are the roots. These are the roots. And these are the factors. These are the factors. Are they related somehow? Do you see that relationship? Do we see that relationship? If I call x equals to 2, x sub 1, and this is x sub 2, what is it? And 2 is x sub 2, x sub 1. 3 is x sub 2, x sub 2. Yes? And we also know that the same two roots can be found by quadratic formula. Can we? We just didn't use it, right? We just didn't use it. Now, the question is it universal? Is it universal? For any quadratic, we have such a relationship. Is it that universal? That for any quadratic, we have such a relationship? Okay, about 200 years ago, there's a French mathematician. He noticed that. Okay, he also noticed the following things. Okay, he also noticed the following things. If you add 2 and 3, okay, if you add x sub 1 with x sub 2, you're going to get 2 plus 3. 2 plus 3 is 5. And the 5 is opposite of this negative 5. Okay, 5 is opposite of negative 5, which is B, ABC. And he also observed, if we multiply x sub 1 with x sub 2, it's going to be 2 times 3. This is not a proof, okay? This is not a proof. This is just inspire us to start observe. The actual proof, we can also do it. The product is 6. 6 is exactly the 6 here. Do you see that? Which is a C, which is exactly ABCC. Remember the general form? We have ABC, right? A is 1, B is negative 5, C is 6, positive 6. And then his question is this universal? Is this always true? Right? Well, in this observation, our A is what? A is 1. A is 1, right? Now what if A is not 1, right? What if A is not 1? Like in the one we just did. A is not 1. Does it also have this relationship? Okay, so we're going to observe this one. We're going to observe this one. Right? And we have the factors. We have the products, right? We not only have the products, we have the factors. Let's observe. Let's continue to observe. Okay, so right now we are observing and we're not a proof. This is not a proof. This is just observing. You observe certain phenomena and then you say, hey, that phenomenon is interesting. Could this be universal? If it is universal, then that's great. We found some new patterns, right? We found some new patterns. But if it is not universal, it's only specific for these cases. And of course, we cannot make it applying to other cases. Okay, so we're going to continue the observation. And what we see here is that, suppose this is x sub 1. Okay, I want you guys to be very creative, okay? And at this point. But at least, of course, I'm also guiding you. Okay, so we're still going to observe x1 plus x2. And we're also going to observe x1 plus multiply x2. Could you tell me what you get? Could you tell me what you get? If I add x1 with x2, okay? Oh, sorry, this is a positive 7/6. I'm sorry, I made a mistake. Okay, this is positive. My bad. Okay, I'm sorry, guys. There's some 2 chat message. I'm sorry. Oh, Mikhail already pointed out. I'm sorry. Thank you, Mikhail. I'm sorry. I didn't see that message. Okay, thank you so much. Okay, and Cortland agreed. Cortland, I'm going to answer your question that you posted in inbox. Okay, so please remind me and keep me on that case today. Okay, thank you. All right, so are you observing with me? So we have x1 plus x2. Okay, and x1 plus x2 is -3 plus 7/6. Okay, let me make the font just a little bit larger. A little bit larger. And what do we get here? And when we multiply, what do we get? Right? So that's the question. This process is called discovery. Okay, just like in physics and chemistry, there's a process of discovery. In the situation, very good. X1 plus X2, Cortland got a negative 11/6. Do you guys agree with him? Just find common denominator, right? So it's a negative 11/6. Negative 11/6. What is a negative 11? Remember what we did here? It's not exactly the opposite of B. This is 11, positive 11. Well, it's still opposite, but divided by A. 6 is A, remember? So this is the opposite of what? Of what? Of B over A. If this one is also opposite of because in the first situation, A is equals to 1. A equals to 1, right? A is equals to 1. So that's, in this regard, they're the same. You follow me? Let me put it simply this way. Negative of B over A. So in one case, we have A equals to 1. The other case, A is not equals to 1. Right? Now, Cortland also gave us the product, which is negative 21/6. Excellent. What is a negative 21? Negative 21 is exactly the C, okay? And the A is 6. So this is a negative C over A. And here we got C, because that was in the case of A equals to 1. So C over 1. So we found a very interesting pattern. And this observation, okay, so first of all, this observation, remember when we were reviewing quadratic, right? We'll do everything quadratic, right? And the factoring technique we just talked about, this technique, okay, or the technique we just talked about yesterday, is actually based on this observation. Okay, it's based on exactly this observation. So this technique, any way you play it, is based on this observation. All right, matching the 6, right? Matching the 11. It's all about that. It's all from here. So you wonder whoever invented this method, and he or she was aware of this process. So now the question is it universal? The answer is yes. The answer is yes. And of course, there's a proof. There's a proof. Okay. I wish to give you that tool today so that in the future, whenever you have a quadratic, you know, you have no worries. You will just know the answer. There's one way to get the answer and you will get there. Would you like to know that? You already know the answer, actually. Okay, I'm just going to summarize. Okay, so what is so let me tell you the tool simply, and then I will demonstrate you the proof. Okay, the proof is something you can do. If you do it, it will greatly enhance your algebraic skill. But let me tell you the answer first. Okay, so ax squared plus bx plus c equals 0. This is a quadratic form, okay? Provided a is not 0, right? Remember, we solve quadratic, we have learned 3 ways to solve quadratic, right? Factoring, completing square, and quadratic formula, right? We learned 3 ways. Okay, and at the you know, prior to this, we have done everything quadratic, right? We've done everything quadratic. That was relying on completing a square, and we have a different perspective. Now we are revisiting quadratic topic again, but this is under different light. Okay, this is under the light that with every real polynomial is guaranteed to be factored into linear and irreducible quadratic. And if we want to factor completely or whatever, and we can handle it, then the entire factoring polynomial issues is solved. Okay, because we have those theory guarantees, it's just a matter of how to handle to handle our specific questions. Okay, so to deal with the quadratic, if we can deal with the quadratic, a linear is simple, right? We're done, and then we're done. We have resolved all the issues about factoring. Okay, so in the quadratic case, not only irreducible quadratic, for any quadratic, okay, for any quadratic, what is it? Okay, so if we can, whether it's a 0, right? This is the if statement. We understand this is the if statement, right? So we can find the x1, okay? X1 is going to be 2a under negative b. This is a quadratic formula, right? We know quadratic formula works for any quadratic, right? So that's b squared minus 4ac, right? So x1, I'm going to call it minus. x2, I'm going to call it the other one, plus, right? So we got x1, x2. Not only we can find the roots, we can always find the roots, right? Because of quadratic formula. And also for that statement, okay, this is the if statement. For that statement, and we can factor them into what? Into a, okay, still the same a, multiply x minus x sub 1, x minus x sub 2. As simple as that. That's it. Okay, and it is universal that we can demonstrate, okay, what is more, okay, what is more is x1, x sub 1 plus x sub 2 is equals to negative b over a. Oops, sorry. Okay. and x1 multiply x sub 2, and that is equals to c over a. So when you check your answer, you can either go back to the original equation or you just check these two. You just check these two. For example, right? I'm waiting for you guys to write it down. Did you guys write it down? Should I write down all of these? A, B, C. Write them down. Okay, we're going to go back to the two examples we just did to verify that. Okay, we're just verifying, right? So this will give us another tool. This will give us another tool to check your answer. Write it down. Okay, and this is also the foundation for the factoring techniques. Okay, this highlighted part is also the foundation for the factoring techniques for trinomials. Okay, this is the foundation for factoring techniques for trinomials. Okay. Although this is a very useful piece of information, I personally haven't seen it written in any recent textbook. Okay, even though it's a very interesting piece of information. Okay, I didn't read all the textbook from cover to cover, but I haven't seen it. Okay, so if you want to look for resources regarding this theory, regarding this proof, right? So we're going to get to the proof, okay, just in a second. Okay, did you write it down? So, but I want you guys to thoroughly understand this, okay? Because a quadratic is such a prevalent academic question, right? We want to be able to solve it. Okay, we want to be able to just have a complete picture of it. And here we are, okay? Now let's take these, go back to the question here. You find your roots, right? In your mind, you just check these, or you're on your scratch paper. If these are true, right? 5 is -5, is the opposite of -5. And 6 is exactly that. The product is exactly that. You knew you get the right answer. You're good. You're good. Now, how about these? We have just checked, right? We have just checked. How about composing factors? Right? This doesn't seem to be, I'm sorry, here. Composing factors. The only issue we have here is about composing the factors, right? So factoring these guys, how does that what we learned? Because this seemed to be rather straightforward. But what about these? Right? Because from what we have done is this, right? This 3 equals to that guy, right? And 6 is here. X1, what is X1? X1 is -3. X1 is -3. So, well, at least I choose it to be, right? So X1 is -3. Okay, be careful. You always subtract. Okay, it's just always subtract. X2 is 7/6. Okay, you have to work a little bit. So you need to know how to work it. Okay, X minus -3, and that's going to be X plus 3. Okay, so that's x plus 3. And you're going to take this 6 and move it here and bring the 6 inside this parentheses. Okay, so sometimes it requires a little extra work to make it seen. So you get 6x minus 7. You see, it works every time, isn't it? Well, of course, we didn't try every time, but we get to practice this for the following questions. But now, what is the proof? What is the proof? Are you ready to prove it with me? Okay, in fact, I encourage you guys to derive quadratic formula. I don't know how many of you have ever derived quadratic formula. Okay, if you can make yourself derive quadratic formula and you make the entire process complete. Okay, and I'm sure you're going to enjoy that immensely. So we're going to prove this one instead of, doing quadratic formula, right? Deriving quadratic formula, you can find that in intermediate algebra textbook, maybe even in pre-calculus textbook. Okay, those are pretty common. Okay, if you like, I can get you started. But right now we want to prove these two. Okay, is a universal, right? Is a universal. So we want to prove this guy. Okay, we want to prove this guy. Now, x1 is here, x2 is there, right? So x1 plus x2 is equals to this guy adding the other guy. Yeah? We already have the common denominator. So I'm going to keep the common denominator, 2a. Well, let me make it larger so everybody can see better. Okay, so the numerator is adding the numerator. Okay, plus, and this is going to be like that. Okay, so what do you see? Plus the square root minus the square root, that makes 0. You guys follow me? And the next step, what do we get? These two opposites are going to be gone. And you get a negative 2b. Two and two reduced. You get a negative b over a. Is that proof pretty easy or what? Okay, so we have proved this part. Okay, so we're proving these two. Okay, I'm just want to make these titles clear. How about multiplying? Multiplying is right here. Okay, multiplying, that's multiplying. And what are we going to do next? Right? x1 multiply x2. Denominator multiply denominator. So that's going to be 4a squared. Numerator, we have this guy multiply the other guy. What do we have here? We have negative b minus something and negative b plus something. So it's a minus b multiply a plus b situation. Is that right? We are in that situation, aren't we? This is a capital A, capital A, capital A, capital B is the square root. Do you see that? So we have a minus b times a plus b situation. So we get a squared minus b squared. Okay? Or you can just directly FOIL. I prefer using this formula because it will produce neater steps. Okay? So the denominator is still 4a squared. And the numerator, I'm going to apply the a squared minus b squared. And my a is a negative b. Negative b squared, right? That's my capital A. Minus the square root squared, the capital B. And next, okay, 4a squared stay where it is. Negative b squared is the same as b squared. Minus, remember this thing we have learned before? We have reviewed. Yeah? What is it? The square root of that is equal to what? X, right? In comparison with the square root of x squared equals to absolute value of x. Yeah? So that squared is just simply equals to b squared minus 4ac. There. Last but not least, we opened up the parentheses. Right, this turned to positive. B squared minus b squared is gone, right? So what do we have in the end? B squared minus b squared is gone. We don't need the positive sign. 4 and 4 reduced, a and a reduced. We ended up with what? C over a. Proved. This is the proof. This is the proof. Okay. So we have just proved that these are true. These are true. Okay. And these are, of course, we know the importance, right? It is in the design of factoring techniques you have learned in elementary algebra. Okay, so the different teachers teach a different way. They learn from their teachers and so on and so forth. For example, I learned from my teachers, and only sometime later I discovered, I learned, oh, it's from here. It's from here. Okay. Back to another topic. I encourage you guys to derive yourself quadratic formula. Then you will make the whole thing complete. You'll make the whole thing complete. Do you think you want to do that? Or shall we leave that for tomorrow? How about we get started today? Okay. These processes that we just went through will greatly enhance your algebraic skill. That's the other reason I encourage you to start deriving. Okay, you need to be able to handle multiple steps. Did I put on recording today? Oh no, I did. Okay, for some reason I thought I forgot. Okay, I didn't. Most of our students entering calculus classes, they are in great need of enhanced algebraic skill. But then you say, how do I enhance my algebraic skill? And people will tell you, practice, right? And everybody tells you practice, right? You say, oh, how could I become like, playing basketball like Magic Johnson or Kobe Bryant? And people tell you, practice, right? Same reason. But these will bring you to be able to handle these situations will bring you to the next level. Okay. So today, just for the fun of it, we are going to derive quadratic formula. How about that? Okay. So plus minus. I'm going to get you started, okay? Because I promised Portland I'm going to answer some questions that he posted in inbox. Okay, I'm going to get you started. The deriving of this formula actually started from what? It actually started from completing a square. It was done by completing a square. Okay, we have done so much completing a square in quadratic, right? So I think you guys can handle this. What's been done here is that the first step of deriving quadratic formula is divide everything by a. Okay, of course, this divided by a is still 0, right? So dividing by a, step 1. Step 2. Okay, step 2. Step 2, we're going to make a perfect square. We're going to make perfect square. So in order to make perfect square, we're going to move this guy to the other side. We're going to move this guy to the other side. So we're going to add something to make that perfect square. Add the same thing on both sides. Okay, we're going to make perfect square. Make perfect square on the left. How do you make a perfect square on the left? You take this quantity, excuse me, you take this quantity divided by 2. So b over 2a and squared. That will make the perfect square. Right? And the source of that inspiration is you have a squared plus 2ab plus b squared. Okay, a is x, 2b, and this is b. Do you see that? 2b is b. In other words, we have the x, and this guy is 2b. Okay, and half of 2b is b. So that's why we divide it by 2. Okay, all right. So put that aside, we now get the perfect square. So we get x plus b over 2a squared equals to, and what do we get here? Right? We get negative c over a plus, now I'm going to make this just write it normally. Okay, we get a b squared, and this is a 4a squared. Or a squared. And we're going to find common denominator. And that common denominator, what is that common denominator? 4a squared. So we have just 1a, right? So the 4a, we want to make it 4a squared. And we're going to multiply what? We're going to multiply a 4a. In order to make that 4a squared. 4a squared. Okay. So now here you have a 4ac plus that guy. You guys follow me? And next, we have the common denominator. We have the 4a squared. And we have b squared minus 4ac. You can see that how that come, where that came from, right? Minus 4ac plus b squared is the same as b squared minus 4ac. So finally, we get to this point. Equals to this guy. Right? And then we're going to take square root on both sides. The right-hand side, the left-hand side, let's see how we handle the left-hand side, right-hand side. The left-hand side is going to be absolute value of x plus b over 2a. On the other side, what do we get? We take square root of the top. That's the square root of b squared minus 4ac. We take square root of the bottom. That's a 4a squared. Okay. And what happened to 4a squared? The top and the 4a squared equals to 2 times absolute value of a. Right? Absolute value of a. Yes? Because the square root of a squared is absolute value of a. Yeah? Now, we have reached to this point. We've reached to this point, right? And this is absolute value equation. So x plus b over 2a is equals to plus minus this guy. Okay, and now this is the place that we're going to have some interesting discussions. We're going to have some interesting discussions. This is the plus minus the absolute value of a, right? So a is going to come out either positive or negative because this sign will be combined with the plus minus. Okay, because the absolute value of a, it either comes out as a or negative a, right? So that whether positive sign or negative sign, so that's going to be absorbed into 2a, and the top is plus minus b squared minus 4ac. So you need to understand that this plus minus sign and absolute value of A, they just combine together. They just combine together. Okay. And last but not least, we're almost there. We're subtracting B over 2A. So that's become negative B over 2A. Okay. And over here, you have a plus minus, right? So we have a plus minus of square root of B squared minus 4AC over 2A. Do you see quadratic formula now? Same denominator, 2A, negative B, plus minus B squared minus 4AC. Okay, so that's the deriving of quadratic formula. It probably doesn't look very hard for you anymore, right? That means you're getting better. You're getting better. But I still encourage you guys to do it using your own hands. Okay, using your own hands. Just this will greatly enhance your algebraic skill. Will you have to be able to derive this in calculus class? The answer is no. But you're going to derive a lot more other stuff. So deriving is a basic skill. You want to make it stronger. You want to make it stronger. But anyway, without further ado, we do have more questions than 37, but I promised Cortland I'm going to answer his questions regarding something we did. What we did on Monday? Is that right, Cortland? Yeah.
Yeah, it was on Monday.
It was on Monday. So let's open that file. Monday 17th. Okay. So his question, your question is where?
It was the, wait, let me see. Hold on.
So why we make these, right?
Yes. Yeah.
Is it here?
Yeah, it is. Is that one?
Something like that, right?
Yes.
Okay. Your question was why we want to go from X to absolute value of X, right? The reason is here. We want to bring this X to this place. We want to bring the X inside the square root. Do you follow me?
Yeah, I'm following.
Okay, but X itself is negative because X is approaching negative infinity. Do you follow me?
Where does it say that? Where does it say that it's approaching negative infinity?
Here.
Oh, okay. Okay.
Okay, because X is negative, the absolute value. So we're going from here to here and to here. And because X is negative, so we're going through this branch.
Okay.
So X, because X itself is negative, so X is going to be negative of absolute value of X. So here we have some deriving there. Okay, do you follow me?
Yes.
Okay, because let me use that symbol to explain. Where's my lovely symbols? Because there's usually a because sign. Anyway, BC, okay? BC. Because x is negative, okay, it's very important for you to know. The absolute value of negative, the absolute value of a negative number is its opposite, right?
Mm-hmm.
And in this case, x is negative of absolute value of x. Okay? You just multiply -1 on both sides.
Right.
Okay? Oops. So we get there. And the absolute value of x is the square root of x squared. You know what I mean?
Yeah, I got it.
So that's how we go. You see, from here, we get here with a negative sign. You got it?
Yeah. So you were just trying to put the x under the radical, under the square root.
Correct.
I got it. Got
Okay.
it.
What do we want to do? We want to put this x, okay? We want to bring the x inside here.
Yeah.
So we can operate inside. You follow me?
Yeah.
We take the x, divide into each. We get a 4 plus 3 over x.
Mm-hmm.
So, but we have to go through these steps to get there. We have a negative sign as a consequence because x itself is negative.
Got it. Got it.
Okay. But most of the textbook, they would not show you these intermediate work. Okay. Most of the textbook I have seen, they don't show you step 1, 2, 3 in between. They just go from here to there. You follow me?
Yes.
And we need to fill it in.
Mm-hmm.
Okay. Does everybody understand? Okay, because I'm sure your question is not yours alone.
I understand now.
Okay, good. Thank you.
Mm-hmm.
Thank you for asking. Okay. I want you guys to understand, you can ask me questions anytime, anything, on anything. Okay. So just never hesitate to ask those questions. Okay, because all these little details, if you don't work it out, it's going to come back to haunt you. Right? The devil's in the details. The devil's in the details. Anyway, so I'm going to put this away. So we derive all of these. So let's continue. Right? So we were at number 9. We were at number 9, number 11. How about we do 11 for a change? Yeah. Back to basics 37. Okay, we're doing this exercise also reflecting on the theories we covered yesterday. Okay, because only by doing so, we can get, we can get better to understand those theories. Okay, I keep telling my student when I was teaching calculus class, I said, well, you guys taking calculus class, that's great, right? But at the end of all of these, what do you walk away with? Right? You finish your calculus class and you're done. So have you learned something? What you should really walk away with is the theory, the understanding of the theory. Therefore, you can apply those theories to other things you're doing. Okay, it's not about those exercises. Those exercises is to enhance your understanding of the theory. Do you follow me? I will show you my collections of the theory, theorems and stuff when I was teaching calculus. It's a PowerPoint of how many, more than 100 slides. More than 100 slides. Those are the theories you are going to learn just in calculus 1 alone. Okay, and at the end of the core of that class is hoping that our student will walk away with, understanding those theories, because if you don't understand, you certainly wouldn't be able to apply. So these algebraic skills is just to support you to understand those theories. You know what I mean? So those theories is really the centerpiece, All right, so on 11, so what I want you to be able to do, okay, you look at this. Okay, factor. Okay, on the other side, it's solving, right? It's just, one is a statement and the other one is an if statement. This is what I want you to understand. One is a statement, one is if statement. And this piece is just two factor. And our theory guarantees, yes, we can. Okay, so in your mind, you know, oh, I know fundamental theorem of algebra. This can be factored. And how many factors do I expect? I should expect 2. So you knew you're going to get 2 factors before you get them. And now, how do I find those factors? You try this technique, you try that technique, but you know you have one method that works for all, which is what we just learned, right? Which we just covered, right? And what is it? There. Right here. Right here. Okay. Now, so we know that this is A. A is 1, right? A is 1. So this is going to be 1. So we're applying that, right? We're applying that result. Yes. You're applying that result. So this is 1. So this is going to be x minus x sub 1. It's always minus, okay? X minus x sub 2. But how do you find your x sub 1, x sub 2? You're going to have to solve this equation. And what is that? What is the solution to that equation? Quadratic formula. Right here. Right? So your x sub 1, x sub 2, right? And you can say, oh, x1, I'm just going to write it this way. Okay, this is a plus minus. A is 1. B is 2. B is 2. A is 1. C is, A is 1. C is, what is C? C is 5. Okay, so we're going to encounter complex numbers now. And complex numbers, if we have real number coefficients, the complex roots always show up in pairs. That's the conjugate theorem we learned yesterday. Right? Now, let's talk about these theories. If you have real number coefficients, your complex roots or your complex factors, they always show up in pairs of conjugates. So before you get there, you already know what to expect. Do you follow me? This is the power of theory. Before you get there, you already know what to expect. Okay. All right, so let's continue. The rest is just a detail. The rest is a detail, okay? Is it important for us to be able to handle those details? Of course, it's very important, right? That's why I'm telling you, you need to enhance your algebraic skill, right? But you're doing it. That's great, right? So 4 minus 20, that's negative 16, right? And then we have a situation that we have a complex numbers. Okay, so I'm going to do this in this comparison so that you will, so this is a plus minus negative 14, negative 16. This is going to be like just what 4i, right? It's just 4i. And that equals to, if you reduce the 2, right, you're going to have a negative 1 plus minus 2i, right? So your x sub 1, is going to be negative 1 minus 2i, and your x sub 2 is going to be negative 1 plus 2i. And you got your x1, x2, and then you come back to this side, to the statement, right? This is the if statement, and this is the statement. And then you just plug in. Right? You plug in your x1 in this place. Sorry. Right? If you like, you may make it a bracket. The next one, you make it bracket. And x2, you're going to bring it here. Do you guys see that clearly? Yes? Okay. You found your factors. Do you see that relationship being used? Do you see that? Okay, and you can check your answer by adding them, right? You can check your answer by adding them, multiplying them, and they should equal, they should match the opposite of B, and they should match of 5. Do you guys see that? And last but not least, you do need to organize your term a little bit. Okay, you're going to open up the parentheses over here. So is it going to be plus? Okay, this is going to be plus. And this piece, you open up the parentheses, and this is going to be plus, and that's going to be minus. Okay, and then you can use the parentheses back. But these are minor details. You can keep your bracket. That's not a problem. In the whole theory, in the whole question here, we answer the question because in your algebra class, you might learn that oh, this is a prime. No, with fundamental theorem of algebra, with the existence of fundamental theorem of algebra, there's no such thing called prime. Every polynomial can be factored, right? Every polynomial can be factored. But this one is one of those we call irreducible quadratic. Irreducible quadratic means that, you know, you're going to get to complex factors. Okay, well, I didn't get to write a textbook. If I write textbook, I'm not going to introduce the word prime. I would have covered these. Okay, nobody's hiring me to write a textbook. I'm sorry. I don't feel sorry for myself, but that's okay. Okay, this is the useful stuff. This is the useful stuff. Okay, that theory exists, right? Those so-called prime, I understand the reason, the reasoning of the author is that you cannot use the technique we learned to factor. That's why. But just because we don't have the mean to factor doesn't mean the factor don't exist. You know what I mean? Just because the mean we acquire doesn't mean the factor don't exist. These theories we covered yesterday it's telling us, hey, you have them. You just haven't found them. So there's a difference between the solution exists versus we haven't found the solution. You follow me? And in the future, as you study differential equations and all of that stuff, you will realize that you will learn that, to prove the existence of the solution versus actually find the solution are two separate matters that handled by mathematics, because we have to. Sometimes we can demonstrate, hey, the solution exists, but we couldn't find it. This happens a lot in mathematics, and I wouldn't be surprised this happens a lot in engineering, in other fields. There's a solution, but you couldn't find it. And that shows, if a theory could show you that, oh, this solution exists, right? It at least tell you, keep looking. If there's a piece of theory tell you, in this circumstance, the solution does not exist, and you can stop searching. Make sense? So that's the power of theory. And we need to thoroughly understand these theories as they apply. Okay, our time is almost up, and I want you guys to continue what we have done today. Okay, do those deriving. Okay, this will personally enrich your algebraic skill, and also reflect on the theories we talked about yesterday. And tomorrow we're going to wrap this up. Okay, we're going to wrap up all of these, and of course the key of doing this, the whole reason that I'm doing this, is because I want you guys to really reflect on these theorems in the future, right? For example, if you have a polynomial in your calculus class, right, in the middle of finding derivative and stuff, you may have a degree 3 or degree 4. And if you have to factor, and before you found those factors, you have them. They exist. You just haven't found them. Okay? So what are the tools you can use to find them? Long division, right? Of course, the factoring techniques you're familiar with, right? If those don't work, you have to try other means, because they're there. They're there waiting for you to discover. And so all these different ways you want to try different ways. That's all about learning mathematics. Learning mathematics is not about rigidly just doing things one way. No, you have to open your mind to try this way, try that way, try this way. And it should open our mind, not to close our mind. Okay, so I also suggest, okay, by the quadratic we covered today, okay, combined with the quadratic we covered before, I want you guys to do a little summary for yourself. Okay, that will be amazing for you. That will be amazing for you. That will make that entire quadratic topics complete. Remember, I encourage you to summarize. Right? When you learn something, summarize. Put these two together. You will be invincible when a quadratic is encountered. Why quadratic is so important? Because this is one of the most used topics, I would say used tool for academic reason. And not only for academic reason, even in mechanical engineering, in other fields, they also use a quadratic. Okay, to get better approximation and so on and so forth. All right, so quadratic is, and the good news is we know everything about quadratic. Okay, there are things we don't know thoroughly. But for quadratic, we know everything about it, and you want to know it, right? Because in the field of mathematics, we already know everything about quadratic. No secret. There's no secret. All right. So without further ado, and I applaud you for asking those questions. and keep on asking those questions, okay? And explore and think and ponder. And I will see you guys tomorrow, and we will continue these topics. And I shall have a quiz out as soon as possible. And yesterday I was a little lazy. Okay, I did a quiz for one class and I didn't do a quiz for this class, but you should still expect 2 quizzes this week. Okay, and good job, and I will see you tomorrow. Thank you.
Thank you.